Hello students, today we are deriving a relation between the drift velocity and electric current flowing through a conductor. In the last session, we derived an expression for the drift velocity of electrons in a conductor. We know that the drift velocity is the additional velocity other than the random thermal velocity of the electron gained by the presence of external electric field. Under the presence of an external electric field E, all the electrons gain an additional velocity other than the random thermal velocity, and we know that the expression for the drift velocity Vd is equal to E by m into relaxation time. In the vector form, we can write as drift velocity Vd is equal to minus E by m into relaxation time. The terms are Vd stands for drift velocity and E, small letter e, for the charge of electron. Capital E is the strength of electric field. M is the mass of electron and tau is the relaxation time. Means the average time interval between the two collision for the electron. This is the expression for the drift velocity, and with this velocity all the electrons are moving opposite direction of electric field. This velocity is too small. It is in the order of 10 raised to minus 5 meter per second. It is too small. And today let us see what is the relation between this electric current and drift velocity. For that, here we have a conductor of length L and area cross section A. Here a conductor having an area cross section A and length L. With the help of a battery, we are applying a potential difference V between the end of the conductor. A potential difference V is applied between the end of the conductor, and we can write the expression for the electric field on this conductor as the electric field through this conductor can be write as E is equal to V by L, where V is the potential difference between the end of the conductor and L is the length of the conductor. So electric field through this conductor can write as E is equal to V by L. Now, because of this electric field, all the electrons, this is the direction of this electric field, this is the direction of electric field, and under this external electric field, all the electrons experience a force, and because of that force, all the electrons are moving opposite direction of that electric field. The direction of free electron is shown here. With a velocity Vd, all the electrons are moving opposite direction of this electric field. Now let us say n, small letter n is the number density of the electron. Number density of the electron in this conductor. Number density of electron in this conductor. Number density means number of electrons per unit volume on this conductor. Number of electrons per unit volume of this conductor. Let us say n is the number density of electron on this conductor. So the total charge on this conductor can be write as the total charge on this conductor. We can write as Q is equal to the charge of one electron E into total number of electron on this conductor. The total number of electron can be write as number density of electron into volume of this conductor. What is the volume of this conductor? Volume of the conductor can be write as A into length, area cross section into L. So this is the total charge on this conductor. The total charge on a conductor of length L can be write as E into N into A into L. E is the charge of one electron. N is the number density of electron on this conductor. A is the area cross section and L is the length. A into L stands for volume of the conductor. Volume into number density. They are getting the total number of electron on this conductor into magnitude of charge. So this actually give the total charge on this conductor. Let us say it is Q. And we can say all the charges that enter from the right side of this conductor, will pass through this conductor and come out to the left side of this conductor. After a time, we can write that after a time t, all the electrons which is entering from the right side of this conductor will leave this conductor through this left side after a time t. How can you write the time? Time is equal to distance traveled by the conductor by velocity of the electron. Actually, this is the distance traveled by the electron while moving through this conductor, because L is the length of the conductor. This much distance traveled, L, by velocity actually give what is the time taken by the electron, all the electrons or all the charges pass through this conductor. T is equal to L by Vd. Now let us write what is the expression for the electric current. The electric current can be write as I is equal to charge by total charge by time. Total charge by time. What is the total charge passing through this conductor? This much charge is passing through the conductor in a time t. So the current can be write as I is equal to Q by T. So that's substitute for Q. Q is equal to E into N into A by L. Sorry, A into L. This is the total charge on this conductor by time. Time can be write as L by drift velocity. L by drift velocity. Now rearrange this equation. We can write I is equal to current I is equal to one of the L getting cancelled, and current I is equal to E into N into A into, we are taking this Vd to here, that is Vd. That is, can rearrange this equation in another form. I is equal to N E A into drift velocity. So this is the expression for the current in terms of drift velocity. Current I is equal to N E A into drift velocity. Here I stands for the current passing through this conductor. N is the number density of electron in this conductor. It means the total number of electrons in a unit volume. E is the charge of electron. A is the area cross section, and Vd is the drift velocity. So this is a relation between the current and drift velocity of electron in a conductor. We can write an expression for the current density from this relation. We know that the current density J is equal to I by A. The magnitude of current density J is equal to I by A. Where the current density is the current passing through a conductor, normal to a conductor, through a unit area. Current density is the current passing through a unit area normal to that conductor. So we can write J is equal to I by A, and know that it's a vector quantity. So the current by area cross section. So the expression for the current density become N E A into, the A is getting cancelled by dividing by A is getting cancelled. So we can write as N E A into drift velocity. As it is a vector, we can write the J is equal to N E into drift velocity. N E into drift velocity. So this is the expression for the current density. Current density J is equal to N E into drift velocity. It is in the vector form. And this equation is valid for both positive charge and negative charge. J is equal to N E V D. Drift velocity, in terms of drift velocity, we wrote an expression for current and current density. Current is equal to I is equal to NEA into VD, and current density J is equal to NE into drift velocity. Now we are trying to deduce Ohm's law from the concept of drift velocity. Let us see. Here we have a conductor of area cross section A and length L. A potential difference V is applied by using a battery. And a drift velocity of the electron can be written as Vd is equal to E by M into relaxation time, where E is the electric field on this conductor. And we can write as electric field E is equal to, in terms of potential difference, we can write as E is equal to V by L. E is equal to V by L. Electric field E in terms of potential difference, E equal to V by L. So we can write the expression for the drift velocity as drift velocity is equal to, we are rewriting the drift velocity as Vd is equal to E into, instead of electric field, we are writing in terms of potential difference, that is E equal to V by L, and M is the M into relaxation time. So this is the expression for the drift velocity of electron on this conductor. Vd is equal to E V into relaxation time by L into M. E stands for the charge of electron. V is the potential difference between the end of the conductor. L is the length, and M is the mass of electron, and tau is the relaxation time of the charge. Now rearrange this equation, and we are writing the drift velocity is equal to, drift velocity Vd is equal to E V by M L into relaxation time. Give it is equation 1. And we already derived an expression for the electric current. I in terms of drift velocity, I is equal to N E A into drift velocity. Drift velocity. Now in this equation 2, substitute the value of drift velocity, right? Substitute equation 1 in equation 2 in 2. Now we get I is equal to, current I is equal to N E A into, instead of drift velocity, we are writing this expression equation 1, that's equal to E V by M L into relaxation time. Now we can write this current is equal to, current I is equal to from this expression E into E is the E square, we can write as E square, so that's I is equal to N into E square into A into V into relaxation time by M into L. So we're making one more rearrangement by taking the V and I in one side. That is, if you are taking that V and I, that's writing as V by I in one side, V by I, and all other terms on the other side of this equation. Then it like this, V by I is equal to, V by I is equal to M into L by all other terms here, N E square A into relaxation time, M L N E square A into relaxation time. And we know that V by I, actually V is the potential difference between the end of this conductor, and I is the current passing through this conductor. So actually we know that the ratio of potential difference and current is known as the resistance of this conductor. And we are writing here the resistance of this conductor R is equal to V by I, instead of V by I, we are writing as R, the resistance of this conductor. R is equal to M into L by N E square tau, and rearranging the equation on the right side like this way, R is equal to M by N E square tau into L by A. So we know that if the temperature and all other physical factors remains unchanged, there is no change for the relaxation time. It will be a constant because relaxation time actually depends on the temperature. And all other factors are constant on the right side. M, mass of electron, is a constant. L, length of the conductor, is a constant. Number density of electron is a constant. Charge of electron is a constant. Area of cross section of the conductor is a constant. So we getting that resistance R of this conductor is equal to M by N is square tau into L by A. The left side is a constant, so the right side all terms are constant. So actually it proves the Ohm's law. R is equal to M by N is square tau into L by A. Now we already know the equation for the resistance of a conductor. The resistance of a conductor usually we are writing as R is equal to rho into L by A. R is equal to rho into L by A. So this is equation 3 and this is equation 4. So now compare this equation 3 and 4. By comparing the equation 3 and 4, the left side both are resistance. Now on the right side, instead of rho, on equation 3, we have M by N is square into tau. And L by A is the. So by comparing this equation 3 and 4, we can write this expression for the resistivity of this conductor, material of this conductor. Rho is equal to M by N is square into tau. M by N is square into tau. So this is an expression for the resistivity of the material of the conductor in terms of mass of electron, number density of electron, charge of electron, and the relaxation time. And this expression shows that the resistivity is a constant for this material. Actually on the right side we have all constant. M is constant, N, E, tau all are constant. If the temperature is not changing, the relaxation time is also not changing. So the resistivity of the material depends on the number density, N, the number density of the electrons in a conductor. You know that the number density of the electron actually depend only on the nature of the conductor. It does not depend on any other factor. It depends only on the nature of the conductor. M and E are constant. Mass of electron and charge of electron are constant. It does not change under any circumstance. And you know that relaxation time is temperature dependent. We discuss how the resistivity depends on the temperature in some other sections. So here the expression for the resistivity rho is equal to M by N E square into relaxation time. Thank you.